In this video, we will be looking at oblique triangle application. So we're going to take various word problems, create an oblique triangle out of it, and then solve for missing sides or angles using sine law or cosine law. So the first problem we have, two hotels are located 400 meters apart on the same side of a river. So right away, let's say this is the river bank and we have two hotels, and I will just label them A and B. Across the river is a dock for ferries to bring tourists to the hotels. So let's say the dock is here, and I'll label that D. The angle from the riverbank at Hotel 1 to the dock is 36 degrees. So let's say this is Hotel 1. And from Hotel 2 to the dock is 59 degrees. So this is 59. How far is each hotel from the dock? Which means we are trying to solve for this side length to see how far Hotel 1 is to the dock, and this side length to see how far Hotel B is to the dock, or Hotel 2 is to the dock. And I forgot to label that the two hotels are 400 meters apart. Now looking at this, I don't have a full pair and I don't have the cosine law set up. However, I can solve for this third angle by doing 180, subtract 36, subtract 59, so that I get 85 degrees for that triangle. Now I have a nice full pair between angle D and the 400 meters. And I'm just going to label across from angle A is side A and across from angle B is side B. So I'm just going to start off with angle A and side A. So we will do 400 divided by sine 85 for our full pair is equal to side A over sine 36. And now we can cross multiply and isolate for A. So A sine 85 is equal to 400 times sine 36. And then we can divide both sides by sine 85. And now pause the video, try this in your calculator just to make sure you plug it in correctly. You might need brackets around the numerator, but you should get 236.0 meters. And if we look at this, side A is right over here, and that's the distance from the second hotel to the dock. Now, I want you to go ahead and set up your second ratios or your second equation to solve for side B, and then we'll write our therefore statement. So go ahead, pause the video, set that up, solve for B, and then come back and check your work. All right, so for your setup, we should have had 400 over sine 85, so that full pair again is equal to B over sine 59. Cross multiply, divide out your sine 85, and hopefully you got 344.2 meters. And then for your therefore statement, make sure you look at your triangle carefully. Like I said before, side A is actually the distance from Hotel 2 to the dock, and then side B is actually the distance from Hotel 1 to the dock. So be careful with that in your therefore statement. Now let's move on to part B. How wide is the river? Now, I am going to redraw this triangle and label all of the new sides that we have been given. So I know that this entire length is 400. I know this is 236.0 meters, and this is 344.2 meters. I know these angles, and I'm not going to label the top angle because if we're looking for the width of the river, I am looking for the height of this triangle, the direct and shortest length from the dock to the opposite riverbank, which is the base of this triangle. So I'm going to label this as X. Now, because this 400 meters is actually part of the oblique triangle, I don't care about that length. It doesn't help me at all. I'm going to pick one of my right triangles so that I can solve for x. And I'm just going to pick the one on the left, but you can pick either one. So now I can see that x is opposite to the 36 degrees. Adjacent is the blank side because that 400 meters is the entire length from A to B. We don't actually know the adjacent side of just that right triangle. And then 344.2 is the hypotenuse. So I am looking for opposite, and I have the hypotenuse, which means I will use sine from SOHCAHTOA. Opposite is x, hypotenuse is 344.2. I can put my sine 36 over 1 and do a quick cross multiplying so that x is equal to 344.2 times sine 36, and we get approximately 202.3 meters. So therefore, the river is 202.3 meters wide. And that's it. So sometimes you might have to divide that oblique triangle to get a right triangle to solve for that height. So make sure you read your questions carefully and you rely on your knowledge of SOHCAHTOA and sine law or cosine law if needed. Now let's try another scenario. Two airplanes leave an airport at the same time, flying at 750 kilometers per hour and 850 kilometers per hour. After 2.5 hours, they are 1,900 kilometers apart. Find the angle between their flight paths. So why don't you pause the video here and try to set up a triangle, what you think it might look like, then come back to the video to see if you are on the right track. So our planes are starting at the same point. So I'm going to label that as let's say the airport. One flies in this direction, one flies in this direction. I will label that A and B. And after 2.5 hours, they are 1,900 kilometers apart. And I'll just label the airport as C to finish off this triangle. Now, I do have the lengths of the other two sides. I'm just going to have to use the speed. So if I know that the first plane travels 750 kilometers per hour, that means in 1 hour, it travels 750 kilometers. So if I want to know the distance in 2.5 hours, I'm just going to multiply 750 by 2.5. And when I do that, I get 1,875 kilometers. And I'll do the same thing for my second plane. So it's flying at 850 kilometers per hour. I'll multiply that by 2.5 and I get 2,125 kilometers. Now I have all three sides, which means I can use cosine law to solve for an angle. And I'm looking for the angle between their flight paths, which means I am looking for angle C. And I am going to use the rearranged version of cosine law. And because I'm looking for angle C, I'm going to be subtracting side C at the end in that numerator, which is that 1900, which means I'm going to have 2,125 squared plus 1,875 squared, subtract that 1900 squared. It doesn't matter the order you put the first two sides, but that 1900 that matches angle C, that has to be the side that's being subtracted. And then all over 2 times those first two sides. Now you can simplify that fraction if you'd like. And when you simplify it, you get 4,421,250 over 7,968,750. And that's what cos C is equal to. And because we are looking for an angle, we are going to take the cos inverse of this fraction. And when we do that, we should get approximately 56 degrees. So therefore, the angle between the flight paths is 56 degrees. Now that's it. Let's try the next one. Jeremy wants to go to Toronto from Edmonton, but he took the wrong road and ended up in Chicago instead. Don't ask me how this happened, it just did. Upon realizing his directional mistake, Jeremy drove from Chicago to Toronto. So we know that the 3 vertices on our triangles are going to be Edmonton, where he started. His goal was to get to Toronto, but he ended up in Chicago for some reason and then went to Toronto. So we weren't given any dimensions, but at least we have our triangle and we can start filling in any information that they give us. If the angle at Toronto is 45 degrees, the angle at Chicago is 95 degrees, and the distance from Edmonton to Toronto is 2,000 kilometers. How much further did Jeremy drive than necessary? So first of all, I see that I'm given 2 angles, so I'm just automatically going to solve for that third one by doing 180 subtract 45 subtract 95, and we get 40 degrees. Now our goal is to see how much further he drove. Well, Jeremy actually drove from Edmonton to Chicago, then Chicago to Toronto. So we need to figure out those 2 distances, add them up, and then see how much more he drove compared to that 2,000 kilometers if he went the correct way. So right now, I see that I have a nice full pair between the 2,000 and the 95 degrees. I'm just going to go ahead and label side E and side T, side C. Because I have that full pair, I know I'm going to do sine law. So why don't you go ahead and pause the video. You're going to have to do sine law 2 times, once to solve for E and once to solve for T. So go ahead and set that up, do your cross multiplying, find the 2 dimensions, and then try to figure out how much further he drove than was necessary. Then come back to the video to check your work. So let's say you solved for E first. You should have 2,000 over sine 95 for that full pair is equal to side E over sine 40. We can cross multiply, so E with sine 95 and 2,000 with sine 40. And we're going to divide both sides by sine 95. So for side E, you should get approximately 1,290.5. So that's the distance from Chicago to Toronto. So I'm just going to label that in my triangle. And now to solve for T. So exact same setup, except that second fraction would be T over sine 45. And hopefully you got 1,419.6. And that's the distance from Edmonton to Chicago. So let's see what Jeremy actually drove. So we have to add up the first distance with the second distance. And we end up with 2,710.1 kilometers. So that's what he actually drove. And if we subtract 2,000, we get 710.1 kilometers. That's how much he drove on top of the original amount. So therefore, Jeremy drove an extra 710.1 kilometers for that silly mistake and not being careful with his directions. So that's it. So make sure for this, when you do read carefully, to finish off the final piece. Some people might have just stopped at solving for E and T and then wrote their therefore statement. but we did need to kind of compare the two distances, what he actually drove and the straightforward distance. All right, let's try our last one. The running track around a park is made up of 3 legs. You know what? Let's go ahead and just draw this triangular running track. The length of the first 2 legs are 425 meters and 558 meters. So let's say this is the first leg. So we're starting here. And then the second leg is here. The angle formed between these 2 legs is 62 degrees. What is the length of the entire track rounded to the nearest meter? Okay, so our goal, because I need to know the entire length, is to find the perimeter of this triangle, which means we first have to solve for that missing side. So I'm just going to go ahead and label A, B, C, and our goal is to find side B. But we have the other ones. And if we look at this configuration, we have 2 side lengths and the contained angle, which means we're going to use cosine law. So why don't you go ahead and pause this video, use your cosine law to solve for side B, and then state the length of the entire track to the nearest meter. Then come back to check your work. So we should have B squared is equal to those 2 sides squared, added up, subtract double those 2 sides, times cos of the angle. And then you get approximately 269,318.6378. And then you're going to have to square root both sides to get 519. Notice I didn't take away any decimals before I square rooted. It's just at the very end where I followed the rounding that the question asked me about. So now I'm just going to write P for perimeter. The first leg plus the second leg plus the last one we just figured out is equal to 1,502 meters. So therefore, the track is 1,502 meters long. And that's it. So make sure you read your questions carefully to draw your triangle properly. Then go back to your normal sine law and cosine law rules on when to use which one.